Yeah, you can start it.
Oh, hello guys, welcome to the live session again. Myself, Channel Daughter, and you're watching School Quiz. From long ago, I was unable to take the live session, but I'm here for your doubts now. So let's clear out all the doubts regarding for chemistry. So this session will be completely dedicated for the chemistry doubts, and from now on, we are getting live sessions from Wednesday and like Wednesday and Saturday for chemistry, right? Wednesday and Saturday for chemistry. So for any kind of doubt regarding chemistry, we have the free live sessions on Wednesday and Saturday. Though you can join us and you can also share our link to your friends and anybody who needs it most for their doubts in chemistry as well, right? So the thing is, many of you are asking about some doubts in class 10 or and class 9 as well. So if you have any kind of doubt with chemistry in your textbook or any other forms, so you can ask us for definitely, and we will try to ensure you with a great answer and the proper explanation of the doubt as well. Okay, so in this scenario, we will discuss about the chemistry that will be mostly asked from the organic section. And in this organic section, most of you are getting confused by naming of compounds, right? That's for sure. The naming, it's a kind of some little bit difficulty for the students who are new at organic and don't know about some specific criteria or the formulas, or we can say the laws for the naming of the compound. So it will be a little bit problematic for them in the organic section of the chemistry for the naming of the compounds and the structural behavior of organocompounds. So if you have any doubt with the organic section, definitely you will be asked for this, and please try to ensure that the naming of the compound should be proper, because most of the time the naming can play an important role just to ensure that your reaction is good or not, or the reaction mechanism based on your uh, naming, to sure it's really good or bad. That depends on the naming of that compound. If the name of the compound is strong and you are doing the reaction with another kind of reagent or substrate, that will be problematic for your reaction and you will reduce your numbers too. Okay. And the second portion, I'm going to discuss about the like naming of the compound and reaction mechanism, right? Reaction mechanism. That is also a problematic thing for the students who are new at chemistry and don't know about the basic things for the chemistry, right? Reaction mechanism, that like how to add reagents together or the substrate together to form the product. Okay, so if I'm talking about reactant and to form product, many of you getting
Sir, I
confused.
have a doubt.
Okay, from which class? Sir?
Sir, class 9.
Class 9. Okay, fine. What's your name? I know your name.
Sir, Palak Kumari.
Okay, Palak. Right. Ask it.
Sir, what is matter?
What is matter? That's a good question. Let me clear it out. Let me clear your doubt first. Right. As you asked about the matter, matter is a kind of form or something that having mass, right? Matter is something having mass without gravity. So many of you are getting confused about what is mass. Mass is generally weight without gravity. Okay. If you remove the gravity, the pure form of total, you can see the weight of that specific body or object, that is the mass. So matter is something that having mass and occupy space and occupy space. Generally, many of the books have written on it, like having mass and occupy space. So what does this really mean? That let me tell you something. Like consider this an object. This is an object. Okay. So this object having a specific mass. What kind of mass? Mass at all aspects in that universe. Okay, in our universe, in all aspects, in all type of gravity, it having a specific mass. So on Earth, it may be like 10 kg of weight, let's say 10 kg of weight. But what about moon? What will be the mass of that object on moon? So we will get seven, you can say like 70% less weight on moon for that specific mass. But what is the mass of that object will be same on Earth and moon as well. And the structure that occupies space in particular area, let's say we don't know about the state of that object. It may be solid, it may be liquid, or it may be gas as well.
Sir, rotate your mobile phone so it will be visible in full screen.
What's it? Didn't get you, sir. Can you tell me?
Yeah, sir. Please rotate your mobile phone so it will be on full screen.
Okay. I thought it was okay, right? Right? So as you can see, any object or anything that having mass and occupies space is considered as matter. And matter having different forms like solid, liquid, and gas. One more state is there like plasma, but it's a non-stable form. So we don't consider it as a stable form of this. So solid, liquid, and gas are the stable form of any kind of matter. Okay. Is there any kind of doubt? No? I hope you understand that specific concept. If you have any kind of doubt, please ask me.
Sir, how was solid dissolving in a liquid?
How the solid dissolve in liquid? It depends on actually. That's the thing. Let me tell you. Wait. Let's consider any object like this. This is solid. Okay. Now look at the composition of that solid. Is it dissolvable in water or any solvent? Or the property of that solid will define how it gets melt or dissolved in that specific solid. Let's take an example. this solid, let's take this solid as NaCl, like salt. So this salt is made up of iron, right? What kind of iron? Like Na positive and Cl negative for sure, right? So these ionic bonds will form to form the crystal of salt, right? When we hydrolyze these crystals in water, when we hydrolyze these crystals, they get dissociated in the form of Na positive and Cl negative. So we have a container here. Let's take a container here. And if we put some salt into it, like this, so we will get the crystals of, sorry, or the ions of NaCl completely dissolved in that specific solvent. Okay. And the solubility of these crystals depend upon following factors like temperature, like the pressure, and the amount or the number of moles, let's say, number of moles of these specific substance or what you have taken. Right? If we take some kind of non-dissolvable thing like plastic, a polymer, or anything else like that will not dissolve in the water, but can be dissolved in different kind of substances or the solvent, then you can tell like these are the substance which can dissolve in specific liquid, and the dissolution of these substances in water can lead to ionic dissociation. So they are formed by ionic dissociation. And the next thing, like if we add sugar, if we add like sugar, the sucrose, though the sucrose can be divided into monomers unit of the sucrose, like uh, let's say C12H22O11, right? So this is the formula of sucrose. And this sucrose monomer unit can form the polymer unit, or we can say the crystal of sugar. And when we dissolve these crystals into water, they'll convert it into the monomer unit. And the organic synthesis of, or we can say the reaction for dissociation of this compound can happen in our body, though our body is completely relatable with this molecule, and our body will get the energy if we break down this specific molecule, right? Any more doubt? So let's continue. You can ask if you have any vendor doubt again. You can ask. No, okay. I think you don't have any kind of doubt anymore. Now, back to our topic, that is
Yeah,
reaction
Rani,
mechanics.
yeah, Rani, she raised her hand, I think. Rani, ask your doubt, beta.
Yes, sir. So my question from
Anybody who are joining this session can ask freely. You don't have to raise your hand. If the
Yes.
doubt of a specific person can complete it, you can ask clearly. Don't you have to wait for that? Okay. If you have any doubt, please ask before, and you tell your name and your class and your doubt as well.
yes, sir. So me Rani from standard 9, and my doubt is that
Rani from
when
class 9. Okay.
yes, sir. So
Okay. What
when
is your
we
doubt? Hmm.
so when we touch the open wire, we feel electricity because human beings can conduct the electricity.
Okay.
And when we and other side of our hand we touch bulb, then it will not blow. And while we touch the human being, the electricity transfer to our body to that person, and that is not happening with the bulb. Why?
Yeah, actually, Rani, this is typical question, and that is belongs to the physics. That is belong to physics. I'm sorry for that, but I will try to explain some concept for you because this is kind of a mixed question, right? This is a question for physics plus bio and chemistry as well. We will use all the three things here for this question. Like for the physics portion, that the electricity travels a kind of waves. Though these waves need some space, or we can say need a medium to transfer. For this, the bio will come into existence. And the biology states that when we are made up of 70% of water, right? Are made up of 70% of our water. Our body is made up of 70% of water. And in this water content, we have different organic compounds. For sure, your question is completely based on the physical terms. Let me explain you the physical terms of that question. Like if we move down with the wave, we need a medium, and this medium helps to yeah, or we can say help electricity to travel from one direction to another direction. Okay, but in our body, when we talk about our body is directly connected with the earthing of the surface, and many of the times we have a small body traveling of the current. Okay, the current is not completely drawn from one end to another end in our body. There is some kind of restriction, though we cannot able to make this current flow throughout our body. So when you asking like if we use a bulb in our one side, if we use
So
one side,
then how the current, when one person is getting current, then how then other person touch
yeah, yeah,
his
we
or
get
her?
the current. We get the current. I'm not telling you that we don't get the current, but the current will be travel for the smallest direction that can be like from hand to like the half portion of our body, like let's say the chest or the shoulder portions as only. It will travel a shortest distance. Like we don't have the medium, or we can say we don't have like uh, what what can we say about the physics? The movement of current for the long direction need unsuckable amount, and the amount that is required to travel from one portion to another portion is quite large. But our body cannot tolerate these such large forces of current, though we will get a shock, but we cannot transfer it from one portion to another portion. So if we getting a shock or the current more than 220 volts, more than 220 volts, let's say, though there are some kind of little bit chances, so we can transfer the current from one portion to another. Like there's a possibility if we get a shock above this to pretty ensure that we can transfer this current to the other portion of your body, because when we get the current we feel it in the whole body, but that's not the truth. This is just because the whole body interact with that specific point, right? If you get any kind of hurt or the cut in your body, that your body will suffer that pain, your complete body will suffer that pain, but the portion that it's cutted or maybe the wound is there, only that portion is affected completely, but your body will suffer that also. So as like if we get a shock, we will get a complete body affected by that, but the specific portion will get the current. Or for the shortest distance, like for the hand to neck or shoulder or the lower portion. Most of the time, we don't get the lower portion current, right? Lower portion, like we don't get the current from waist. If we touch our hands to the circuit, so the current will not flow to our leg, but our body is made up of like complete interaction. All the nervous system completely respond from tip to toe. Though we'll feel that specific thing in our body, but didn't get affected completely. Okay. I hope this must be a little bit clear to you. That's a kind of question that is not in the book, but that's a little bit explanation for your answer question. Right? Is this answer satisfying, or I'm trying to do it much more for that? Is it okay, Sani?
No, sir.
No, it's not okay. Okay, wait. Let me give you an example. See, consider it is an object. Okay, consider it is an object, and let me get this object bend like that, like at 30 degree or something, 30 degree or something, and I'm placing this like that. Okay, so this is the surface and the 30-degree bend of that object. Fine. I have a I have two droplets. I have two droplets of one is for water droplet food, and second is viscous fluid, let's say honey. Okay, so when we drop both the drops together on this inclined plane, on this inclined plane, what do you think? Which will then get first from here to here? If we drop the water droplet here and the honey here, which will be getting first down first? Which will be getting the down first? The water or the honey? The water droplet will get down first and the honey will get down later. Just because of that viscosity, and that's the property of fluids. As like the current flows in the form of waves, as these waves are stronger, the current will flow a long distance or travel out the long distance. But if these lengths are shorter, then we will get what? We will get a lesser distance. We will get a lesser distance. So the current traveling from one direction to another direction requires a medium as well. What kind of medium it is, what kind of property that medium possesses will depend that this current will flow through a section of point to another section of point or not, right? This will completely depend on that medium. That medium is compatible with that current to flow from one direction to another direction without any kind of resistance, without any kind of restriction, then only the current will flow from one portion to another portion, let's say A and B. If we have any kind of resistance or the restriction to travel, we cannot travel from one direction to another direction, but the current will affect this specific region and the whole body will get affected, and whole the human body will get affected due to this current, because we have a sensory nervous system, and that sense of the current will affect our body completely. But the current will flow only to this specific direction or the specific distance only, but our body gets completely affected by that. Is it okay now? Rani, is it okay? I thought this much more. This will be much more helpful now. Yeah. Okay. Anybody who is having any kind of doubt, please ask me. Yeah. Anybody?
Don't wait for the time there. Ask your doubt. Whatever doubts you're having, just ask it there. Okay. Don't wait for the turn there. Just raise
Yeah.
your hand. Whatever
If you
time.
have any kind of doubt, you can
Yeah.
ask freely. Don't wait for your turn, or don't wait for anybody. Like he's going to ask first, or she's going to ask first. Don't wait for that. Ask your question. That's a live session, and we have a limited time for your doubt session. So because we have more sessions regarding with that. So if you have any kind of doubt, please ask for sure. Don't wait for others.
Sir, what is sublimation?
Yeah, what is sublimation? Which class are you from?
Sir, from standard 9.
Ninth standard. Okay. Sublimation is like, let's say, take this object. Okay. Take this compound, and this compound is completely solid. Okay. This compound is solid. What if I say, if I raise the temperature or release the pressure, what do you think? What is the next state for this solid? What will be the next state for the solid? As we learn about, we have three different states, like solid, liquid, and gas. Okay. So when we
Yes.
increase the temperature or releasing the pressure, the solid gets converted into liquid first, right? And the liquid gets converted into gas. Is it okay?
Yes, sir.
Yes.
But what about if the solid get directly converted into gas without changing into liquid? So if this compound, which is mostly solid, converted into gas phase directly, converted into gaseous substance directly without changing into the liquid, this will be known as sublimation. Okay, let me tell you an example. You will listen about this thing, camphor. Have you listened about it? Camphor, commonly used in household pujas and different kind of stuff. Camphor, like, what is kapoor in our daily household?
Yes, sir.
Yes.
Right? So this camphor, if you place this camphor in an open container in your room, or after some time, this camphor will get disappear. Why is it so? Just because camphor having the property of sublimation, like solid converted into gas directly. Is it okay
Yes, sir.
to come to your doubt, right? Any more
Yes.
doubts?
Yes, sir.
Yeah, tell me.
Sir, what happens to the sugar when it dissolves?
What happens when with the sugar when it get dissolved? Okay, right. Wait a minute. As I told you, sugar is made up of the monomer unit of C12H22O11, known as sucrose. Okay. So these monomers formed crystal by adding, and the polymer unit is known as sugar crystal. Right? Okay. When we dissolve this sugar crystal into the water, the bond between these monomers get break down, and we will get smaller monomer unit in water. Smaller monomer unit in water. But they have an intact form of C12H22O11. Okay, we have the intact form for this specific substance. And in our body, we have this mechanism to break these complex molecules and perform function like C6, this C12H22O11 breakdowns into a smaller unit known as the glucose C6H12O6, and this will convert it into CO2, H2O, and some kind of energy, and this mechanism will perform in our body. Okay. Any more doubts?
So,
Yeah. Ask any kind of doubt. If you if you're not satisfied with the answer, you can ask it again. Don't worry.
sir, sir, repeat
Yeah.
once.
Repeat once. Okay. Let me tell you from a different point of view. As I'm taking an example of salt crystal and a sugar crystal. Okay. I'm not going to take this into a deeper chemistry because that's a longer and lengthier portion and is not acceptable at this grade, like ninth grade. So that thing will not be acceptable, and you won't be able to understand that specific concept because that is a chemistry, vast chemistry level. Okay, so I'm giving you a smaller example for that. Like salt is made up of ions. We have a sodium and we have chlorine here. Like okay, so these ions interconnected together and form the ionic bonds. When the salt dissolved in the water, these ionic bonds break down, and we will get the product of sodium ion and chlorine ion in the water. But for the sugar condition, we having a formula for sucrose like C12H22O11.
Sir,
And
what is
as
the
you
full
can,
name of C12, H22, and O11?
what can you ask them what?
Sir, full name of C12, H22, and O11.
It's sucrose. This C12H22O11 is a like C stands for carbon. Okay. Carbon, 12 molecules of carbon, and H for hydrogen. You heard about them, right? You heard about these elements. And O stands for oxygen. Carbon, hydrogen, and oxygen form a hydrocarbon, and we conclude it as carbohydrate. Conclude it as carbohydrate. So the sugar is our carbohydrate form, okay? And these
Okay,
carbohydrates
sir.
defined about like the carbohydrate may be of single unit, maybe of dimers or the double units, or maybe of the poly unit, like polymers. Have you heard about the glucose? You heard about it, right? Glucose. We
Yes,
all know
sir.
about the glucose. Okay. So glucose is a monomer unit, and we have the formula C6H12O
C6H12O2. O6.
O6, right? C6H12O6. We have the formula for the glucose. Now,
Yes,
now,
sir.
now, now, now. Okay, now let me tell you these kind of organic reactions. As I told you, if you don't have the knowledge of the naming of that substance or the formula of that substance, you will definitely get assured about. You don't get assured about that reaction. Let me tell you one thing. Let's add C6H12O6 two molecule together. What we will get? Answer. What will happen if we add 2 moles of glucose together? If I want to add one glucose with another glucose, what will I get? You know what? We will get C12H22O11. And now you are wondering, like, sir, if we add 6 plus 6 is 12, okay, that's okay. But what about 12 plus 12 is it's 24. What about this? Why we will get 22 here? And if we add 6 by 6, we will get what? 12, but we will get 11 here. So is there any kind of distortion or is there any kind of mathematical mistake? No, that is not the mathematical mistake. If we want to add these two molecules together, we need to remove one molecule of water, and it form what? C12H22O11. That is sucrose. If we add 2 glucose, we will get a molecule of sucrose. Let's see, 12 and 12, it's 24, right? But if we remove 2 hydrogen from here, as we can see, if we remove 2 hydrogen from there, and this 12 oxygen is right here, if we remove 1 oxygen right from here, we will get the formula like this, right? That's the chemistry. And if we remove that water molecule from these 2 molecules,
Sir, why
all
we
the
remove only 2 hydrogen?
why? Why? Didn't get you. Please tell me again.
Sir, why we remove only 2 hydrogen?
Why we remove hydrogen?
Only 2 hydrogen.
Only 2 hydrogen, right? Okay. So the chemistry is not only like we have some kind of restriction. We have some kind of restriction to follow the mechanism of the reaction. If we don't follow that specific mechanism, then the compound will form, behave like unstable, right? The compound will be unstable, and there's kind of demerits to form that compound. We use 2 hydrogen for this. We use, oh, wait a minute. We use 2 hydrogen here just because the water molecule having the formula of H2, right? And the structure and the structure is like this, and the structure is like this. This is the oxygen molecule, and these are the hydrogen molecules. They are interconnected by the bond, and this structure having a bend shape. Okay, having a bend shape. So if we remove the H2O from this molecule, or we can say, let me draw the molecule for you so you can understand clearly. The glucose molecule having two structures like R and sorry, R, not R, D, L and L formation. That is dextrorotatory and that is a levorotatory. If you when you're getting the higher grade, like say 11th or 12th grade, you will get to know what is the dextrorotatory and what is the levorotatory. So basically, the glucose should be written like this. When the CHO, or the aldehyde group react with another molecule of glucose like this, then this HO and this H getting removed as water, and the bond will form between these two, like O negative and C positive. This will form like that. So these two structures will join together by another ionic term, and this ionic form will not affected by the external environment. We have to use the catalyst, we have to use any kind of reagent, we have to use any kind of acid or base solution to remove the bond, and this will happen in our body. Like if we chew something, in our mouth, let's say a candy or a toffee, then the sugar molecule will also get digested 30% in our mouth. The sugar molecule get digested along 30% in our mouth also before going to our stomach, because we have saliva, and our saliva contains enzymes which help to digest these molecules by breaking these bonds first, and then after the other bonds. Okay, that is why the chemistry is used some specific reaction thing to denote the complete molecule, and the chemistry uh, allow us to take advantage of these substances without getting the demerits of that substances, because an equilibrium should be there for any of the substance. If there is no equilibrium, then the compound will form unstable, and that is so much dangerous sometimes. Have you heard about methyl isocyanate?
No, sir.
No. If you learn about your SST class, you will get to know Bhopal gas tragedy, right?
Yes, sir.
Okay. In higher class, you will get to know about the Bhopal gas tragedy. Uh, at that time, methyl isocyanate gas is released during the night, and many of the people lost their lives just because of that specific gas. And that gas is so much dangerous just because of their instability. The unstable product released out from that plant and kill most of the people out there, right? So if we form an unstable product we will have to face the issues like that. The instability in the compound can lead to a dangerous thing. So we are trying to get the product more stable as we can like what we can like. If we don't have any kind of stable product, we will completely, or we can say, if the product is not stable, the product will convert it into another form or dissociated in solvent. And the third thing is that turn back to its original form. And the last is no reaction. This is the least possibility because an unstable intermediate can form another thing, another form first. If that substance having any option to convert from this intermediate to this product without wasting any kind of time, this will immediately convert into that specific product. Right? The instability is for the smallest for the smallest time, and the intermediate want to convert immediately into the product because the potential energy down there, potential energy is so much high that time that it wants to get the lower potential energy to form the product. So this is the intermediate stage and this is the product stage. You can see the difference between the potential energy graph. The potential energy for the intermediate is quite higher than the product potential energy. So the intermediate wants to get again back to the potential energy of the product or the lower potential energy. Okay, any kind of more doubts?
Yes, sir. So why we get the disease figure?
I'm not completely audible to you. Like,
Sir, why
please
we
ask.
get the disease figure?
Mm, Wait a minute, wait a minute. Let me clear out the voice first. Yeah, ask me again and try to ask slowly so I can understand the term.
Sir, why we get the disease figure?
Disease or the
Figure.
last word is not completely clear. Um,
Sir, sugar.
Sugar.
Yes, sir.
Why we cannot completely dissolve the sugar in the water, right? Is that your question?
No, sir.
What?
Why we get the disease figure?
Acha, why we get the sugar disease? Okay, 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 okay. Do you heard about insulin? Have you heard about insulin?
No, sir.
No. Okay. Insulin is a compound that is prepared in our body naturally. Our body prepared insulin naturally. Okay. And the work of insulin is to monitor the amount of sugar that should be needed, the amount of sugar that should be needed for our body. If the amount of insulin is not proper, then this sugar will affect our body in a bad way. Okay. So insulin ensure that the regularity of sugar in our body should be proper. Okay. If there's kind of irregularity or is there kind of problem or if the insulin is not proper for the sugar, Our body gets completely affected by that, and after some time, as our as we grow, the amount of insulin in some persons, the amount of insulin is stopped. The formation of the insulin will get stopped, and they need to take injections of insulin regularly to remove the excess sugar from our body, right? So if we get the shortage of insulin, they will term it as diabetes or sugar, right? The disease sugar, the shortage of insulin, or completely lost the formation of insulin in our body, that is diabetes and sugar. And insulin can control the accessibility or the irregularity of sugar in our body. And if the irregularity happens, this will completely affect our body. And this effectiveness or the effectiveness of this sugar from to our body is quite harmful, because excess of sugar can lead to, like, can act as a poison, can act as a poison in your body. Our body needs some amount of sugar, some amount of what say elements, some amounts of carbon. As you can see now, if we have more amount of CO2 in our blood, we get fainted, right? So lesser amount of CO2, more amount of O2, right? But no, we need this O2 in a specific amount as well. If we get more O2 in our body, that's also harmful. So the equilibrium should be attained for our body. Our body and our world and our universe is completely based on equilibrium. If there is any kind of disturbance in this equilibrium, we will face an issue, definitely, for sure. Right? Any more doubt? No? Anybody else having any kind of doubts? We have some lesser time for this session. Please ask fast. We can solve maximum doubts for you. Anybody? If not, then we can end the session from here. Like, we can end this session here. Anybody having doubts? I think not. So let me tell you some important points and aspects that you can add it into your daily life to perform the chemistry well. First of all, learn about elements. That is the basic thing. If you don't know about the elements, that will be problematic for you. And the second thing, the properties of these elements. How many elements are there in our world or in the universe right now, or discovered right now? Discovered right now. What are the properties of elements? Whether it is metal or metalloid, or it is non-metal. Okay. Can these elements conduct electricity or not? Can these elements are formed like covalent bond or the ionic bond after the formation of any kind of reaction? So the basic knowledge for the element is must, and then after only you will understand about the reaction, how the reaction proceeds. So if you don't have the basic knowledge of element, how you can learn about these reactions, right? If you don't know about the alphabet, can we write a sentence with proper annotations or without any grammatical mistake? No, no. That is why we need these alphabets, all the elements to perform this reaction, to form this sentence, right? I hope you enjoy this session, and please tell your friend and share this link again on Saturday, sharp at 6:30. We will see you in the next session. Thank you so much for joining us, and I hope for the better future of you all. And if you have any kind of chemistry doubt, please take these doubts to the Saturday live session. We will be there at sharp 6:30. Okay. So thank you guys. Thank you for watching.